Welcome to Data Structures and Algorithms in JavaScript. My name is Scott Barrett, and I have taught tens of thousands of students data structures and algorithms. And my courses have some of the highest ratings on Udemy in this category. So it doesn't matter if you're a self-taught programmer or a computer science student. Data structures and algorithms are essential. If you're trying to ace the coding interview or just trying to become a better developer, this is the right course for you. By the end of this course, you'll be able to confidently answer coding interview questions on data structures and algorithms, as well as their time and space complexity. Especially if you take the time to complete the dozens and dozens of coding exercises that are included in the course. I want to show you how this course is different from all of the other data structures and algorithms courses out there. Unlike other courses where you spend most of your time watching the instructor type code or write on a whiteboard, I will be using these animations, which makes everything easier to understand, and you can learn it in a fraction of the time. So let me give you an example of how this works. In this situation, we're adding an item to the end of a linked list. And we'll say tail.next equals new node. And if you don't know what that means, watch the animation. That is tail.next equals new node. And then we'll say tail equals new node, and that does that, and adds that into our linked list. And we'll use animations just like this to cover every topic in the course. And those topics are going to include Big O, where we talk about both time and space complexity. Then we move to the data structures section, where we cover linked lists, doubly linked lists, stacks, queues, binary search trees, hash tables, and graphs. Then after that, we move on to algorithms, where we start out with 5 different sorting algorithms. First, in the section called Basic Sorts, we cover bubble sort, selection sort, and insertion sort. Then we move on to 2 sorting algorithms, which are generally more efficient, but are more difficult to write. And those are merge sort and quick sort. After that, we'll do tree traversal 4 different ways. So we're going to cover a lot of material, and a lot of it can be intimidating. But with the animations, it makes everything as simple as possible. And that's what makes it where we can cover this in a fraction of the time. This course is designed to be a completely different way to learn data structures and algorithms. But don't just take my word for it. I have included several preview videos so you can see the difference the animations make. So what are you waiting for? Find out why thousands of students have rated my courses 5 stars, and see what you can do when you learn data structures and algorithms. So in this video, I'm going to do a quick course overview and talk about how you can get the most out of this course. Please watch this video to the end. In the last half of this video, I'll talk about how to access the coding exercises, which are very important. So this panel on the right is what you would see in the course in the browser. And I do have some students that don't want to cover anything conceptual. They just want to get right into writing code. If that is you, go directly to the linked list section and start with the constructor video. So there'll be 2 things I'm going to cover here. First, I'm going to talk about why you should come up here and do these 2 sections before you get to the linked list section. And then I'm going to talk about how to access the coding exercises. So first, let's talk about Big O. And Big O is a way of measuring how efficient your code is. And I'm going to give you just a quick example of where we might apply that. Let's say you're writing an application and you're trying to decide, should you store your data in a linked list or a doubly linked list? So you're looking at a singly linked list first, and the most important thing to you is being able to remove the last item as efficiently as possible. Is a singly linked list going to be most efficient, or would it be better to use a doubly linked list? Would this be more efficient when you remove the last item? Now, it just so happens that a doubly linked list is much more efficient at this particular task. And we'll get into all the reasons for that when we get into the course. But the important thing here is the way we're going to talk about this efficiency is going to be the language of Big O. So there are 3 different reasons you should watch this section. First, we're going to be talking about the Big O of everything we do with every data structure and every algorithm throughout the course. And we're going to be having quizzes on it and spend a lot of time on this topic. So that's the first reason you should watch this section. The second reason is you can see just right here, if you're making decisions on what data structure to use in your code, you need to understand this if you're going to write efficient code. So that's reason number 2, but there is a third really big reason. There's 100% chance when you go into a coding interview that they will ask you questions about Big O. And now this next topic here, classes and pointers, is very short. It only has 2 videos in it. One is an introduction to classes and the other one is on pointers. So first, let's talk about classes. Every data structure we create in this course will be using a class. So when we write the code for a linked list, for example, we're actually creating a linked list class. So it's important to know the basics of how classes work. But the other video, pointers, this is something that trips up a lot of students. So for example, if I ask a lot of students to show me where head and tail are in this diagram, they will say this is head and this is tail. And that is actually incorrect. And the reason is that neither head nor tail are nodes. Head and tail are both variables that are pointers that can point to a node. So head is this pointer. Now it just so happens that it is pointing at this node, but head is that variable that points to that node. And when you have a variable that's a pointer, it has some characteristics that are different than variables that are, say, like an integer. And it will be important to understand those differences. So now let's move to the final topic in this video, and that is the coding exercises. So I'm going to come up here to the linked list section, and I'm going to open this. And then we're going to come down here to the constructor. And as I mentioned earlier, this would be the first place where we are really writing code in the course. And I'm going to click on this Resources tab, and you can see that we have an exercise and solution file. And if you click on these will download, and then you can import those into whatever coding environment that you're using. So this is one way to access the coding exercises. But I do have some students that don't want to download a file and import it. They just want to do it in the browser in the course. And if that's the way you want to do it, just scroll all the way to the bottom. And at the bottom, there's a section called Coding Exercises. So I'll open this, and then you can see up here that same coding exercise for the linked list constructor is down in this section as well. So for the coding exercise, you either download the exercise from the video under the Resources tab, or you do it down here. You don't do both. And the reason is these will both be the same exercise either way. So if you want to get the most out of this course, as soon as we get done with a video where we're going through code, immediately do the coding exercise and reinforce that learning. So I took a lot of time in creating these coding exercises, and they are designed to give you an opportunity to write the code for each topic as quickly as possible. And I think you will find these to be more efficient than writing all of the code from scratch. And with that, that is our quick course overview.